All right, we've got a good one this time. There were a lot of major problems and also a lot of minor problems, and so I'm going to highlight some of the big things that I saw lots of people doing, and then we'll go back and look at a complete solution that is not only right, but also includes all of the little best practices and details. So even people who got all the problems right, you might want to skip to the end of the video for that part because it shows you things that you might not have been doing. So let's actually start with one of the less major ones. When selecting a random element from an array, a lot of people were using a number to describe the length of the array. A better practice would be to use the name of the array followed by .length to ask the array how many elements it has. This is better because if you add things to the array and you forget to change your number here, your code won't work anymore. More commonly, you're writing a method that takes an array as an input, and in that case, you don't even know how long the array is without asking it first. So this is the standard approach for solving this problem. As another note, a lot of people were off by 1. So remember that if your array has 3 elements, the valid indices, the valid location numbers, start at 0 and go up to 1 smaller than the length of the list. So here's 0 through 2. I saw some people like adding an additional 1 in various places, and in this case, 1 is actually the smallest value this expression is ever going to be, because you're saying, let's take 1 and add something to it. But if that were the case, then you would never randomly select location 0, Abe, so that would not work. So that's a good thing to be careful of. It's a really common bug and a really important one. Okay, for this problem, some people just copied and pasted my buggy code and didn't say anything at all about it, which makes me nervous, because the assignment was to understand why does this not work and then to fix it. So the goal of this code was to find the largest, find the index of the largest element in the list. Put differently, we're finding the location number of the largest value in the array. So conceptually, here's what this code is doing. I'm going to talk through it in English, and it makes sense like it should work in English, even though it doesn't. So we're saying, let's assume, to start with, that the location of the largest value is 0. So we're assuming that 9 is the largest value to start. Then we're going to loop over all of the other locations in the list one at a time, and we're going to ask, is the value at this location larger than the one that came before it? And if the answer is yes, let's save this one as the location of the largest that we've seen. So that seems like it should work, if you're just thinking about it in the abstract. But to see why that doesn't make sense, we can go through an example here. So what if the array looked like this? We're starting by assuming that 9 is the largest value, because we're saying 0 is the index for the largest value. Then we're going to start looping at location 1, which is here. And we're asking, is the value at 1 larger than the value at I minus 1? And the answer is yes in this case, because 10 is larger than 9. So we'll save 1, which is the I value where we saw 10. We'll save 1 as the largest index so far. Okay, so we keep going. So I was 1 here, now I is 2. And we ask, is 7 larger than 10? And the answer is no, and so we keep going. And now it's the last time through the loop, I is 3. And we're asking, is 8 larger than 7? Because we're asking, is the array value 3 larger than the array value 2? And in this case, the answer is yes, because 8 is larger than 7. So we take the index 3, which is where 8 is, and we save it as the largest index. And clearly that's wrong, because now we've replaced index 1, which was pointing at the real largest. So the essential problem here is, you're not going to find the largest thing in the whole list if you're only comparing neighboring elements. As you loop through the list, what you really need to do is you need to compare each value to the largest one you've ever seen in the whole list. So what that looks like is this. We're saying, let's assume that the first value in the array is the largest. Let's loop through the other let's loop through the other indices. And then we'll compare the value that we're looking at right now with the largest one we've seen so far. So we're comparing it with the index for the largest, not the one that came right before it. And in that case, as we're going through, if we ever see a number that's larger than the largest, we'll replace it. And now we're guaranteed that when we get to the end of the list, we definitely will have found the largest. So this is a common bug and illustrates some of the detailed thinking that you need to practice doing. It's not going to be good enough anymore to just write code that seems like it works in your head without thinking it through in detail. Okay, here's a couple of important problems. So there's actually two problems in this code that's intended to determine whether or not the array contains a 3, which is different than your actual assignment. Your assignment was slightly more complicated, but this illustrates the problem. So what this code is doing is we're looping through all the locations in the array, and we're saying if a equals 3, return true, otherwise false. So the first problem is a is not the value in the array, a is the location. A is just a number that's 0, 1, 2, 3 like this. So if we want to know if the array values are anything, you actually have to use a as an array reference to get out a certain value. So that's the first mistake. The second mistake was one I saw in a couple of places. Remember that when you hit a return statement, it will exit your method immediately. So as soon as we evaluate the if statement, one of these two things is going to happen. And no matter what happens, we exit. And what that means is the loop is done. We're never going to visit any of the elements in the array other than the first one. So that doesn't really make any sense because like if the first thing in the array is a 5, we'll say, is it 3? The answer is no, so we'll return false. But maybe there was a 3 later on, and we didn't even bother to check it because it exited immediately. So the right thing to do is test for the condition that would let you exit. So if we see a 3, then we can exit immediately because that's what we were looking for. If we don't see a 3, then we don't want to do anything. So there is no else. Because what we want to have happen is we want it to keep looping and test other numbers. At the very, very end, if we've never exited, that means we've never seen a 3, and then it's safe to return false. So this is another very common mistake, but very important one. Okay, last up, let's take a look at some best practices for the interval class. So first of all, a lot of people still aren't marking your fields private. You should mark your fields private unless you have a very good reason not to. And I'm not sure you know a good reason yet. A lot of people were trying to do very complicated things to make sure that the first number that gets passed to the interval is smaller than the second number. Actually, let me show you that because that was cool. So like here's some actual student code. We've got an array list of intervals and they're looping 100 times, and they've got this do while loop right here which is generating random numbers, and only if the random number, like only if low is actually smaller than upper do they add a new interval to the set, and then they keep looping. This is sort of strange code for a number of reasons. But I think the reason why they're doing all of these contortions is because they want to make sure that they're not passing a larger number as the first one, which is great to pay attention to. A different student tackled it this way. They said while they generated the random numbers prior to this, and then they said as long as a is larger than or equal to b, let's keep regenerating them. So when the while loop is over, we know for a fact that b has to be smaller than a, and that's when they add the new interval. So that's all fine, but one thing to point out is that puts the responsibility for getting the inputs right on the person using the interval class. Maybe it would be better for the interval class itself to take responsibility for making those inputs do the right thing. So in my solution, whoever's using the interval class can actually give me whatever numbers they want, and then what I do inside my constructor is I figure out which one is the smaller one, and I assign that to low, and which one is the larger one, and I assign that to high. So this is sort of more user-friendly for whoever is going to be using this interval class. Couple of other things. So I've mentioned this in previous solution sets. If I want to know whether my interval contains a particular value, I just need to test to see whether that value is between the low and the high. So this expression is what you might put in an if statement. You'd say like, if it's true that that num is larger than low and num is less than high, then return true. What I wanted to point out is that this Boolean expression actually contains the true-false value that we wish we were returning. So if this expression is true, we would be returning true. And if this expression is false, we would be returning false. So this is a very succinct way of doing that. Another nice thing is rather than reference my fields directly, I'm going to use my own getter methods, which I didn't show, to get them. And the reason why that's slightly better is because if I wanted to change how my interval class represented the low and high values, I could do that, and this code would still work. I wouldn't need to change it. So in other words, there's a single way of accessing the value we want rather than accessing it through here or through the getter. So once we've got that, the tester can look like this. I've got my array list of intervals. I'm looping 100 times. I'm generating some random numbers. And now I can feel safe just passing whatever numbers because I know my interval is going to do the right thing. Then I ask the user to enter a number, and I parse it. You may not have watched the one where I talked about the for each loop, but this is a loop that does the same thing as an ordinary for loop, where you're going to use it to access each element in a list. Notice that intervals here is our array list. Interval current looks like I'm declaring a single variable to hold an interval object. And so what happens is this is looping through the values inside this list one at a time and assigning each value to the variable current one at a time. So in other words, this is a shorthand way of just looping through all the values in intervals. And now I'm asking my current interval if it contains the user's value d, and if it does, I put it straight in a print line statement, which I can do if I made a toString, which we talked about earlier. So I consider this to be like a very clean solution to the problem. And it's okay if you didn't have all of these things because we hadn't necessarily talked about each one of them. But part of what I'm hoping is that you will remember these things and start to incorporate them in your own programs. So let's take a look at some student answers. I just grabbed the student one at random. So this was for the Dec problem. The student is looping through all of the possible values, starting with 2 and going up to 14, not including 15. And we said that because a deck of cards contains 4 copies of each value, that's what this loop is for. This loops 4 times. And it loops 4 times for each of the I values. So I'm sure that when I say dec.add I, I'm doing it 4 times. Some students chose to leave out that inner for loop and just say, oops, 2, 3, 4, like this. Obviously, your indentation should be good. And that's fine. No, not a problem. Like, that is all still pretty clear. This is a student who is doing the thing that I said. So instead of 4, we should say names.length or addges.length. And then this +1 is actually causing this range to not be valid. So this is going to be a range from 1 to 4, but we actually want it to be from 0 to 3, since those are the valid locations in that list. So a couple of mistakes there. Here for the interval class, the student made the fields private, which is good. They have the thing where if someone passes num1 to be larger than num2, it will actually assign them in an order that doesn't make sense. The getter methods look good. Setters are interesting because once you have a setter method, again, it's possible that when they change the lower value, they're going to change it to be something that is actually larger than the upper value. So you can't necessarily blindly write setters like this. Ooh, good job running the methods. Okay, so the rest of it looks pretty good. Right. Except so this student didn't actually write a method for testing whether or not a value is in an interval. What they did, and what most people did actually, was, let's find it. So they actually have the if statement here. So they have the user enter a value, they loop over all the intervals, and then they say, hey interval, what's your lower value? Hey interval, what's your upper value? And test to see if it's between them. What I was doing was I was putting all of that logic inside the interval itself. So now the user of the interval class doesn't have to know how to do the test. The interval itself knows how to do the test. And that's like one click cleaner. So saying p dot contains target is a little bit cleaner than having the logic all be kind of here. Here's a solution to the problem for whether the array contains a 1 or a 3. They're looping through all the values in the array, and they're saying, is it a 1 or is it a 3? If the answer... I probably should have said... We probably should have called this something else. We probably should have called this doesn't contain 1 or 3. Because that's what we're trying to test for. So if we see a 1 or a 3, we know that it's not true that it's missing a 1 or a 3. So it's safe to return immediately. However, if we don't see a 1 or a 3, we need to keep looking for them. So that's why we don't have an else, and we go back up to the top of the loop. And only at the very end, if we've never seen a 1 or a 3, is it safe to return true to say, hey, we've never seen a 1 or 3. Wow. This is a very, very confusing method name because it's like the logical opposite of what the method's supposed to do. That was my bad. Sorry, guys. I'm going to go back and change that. So if that was part of your confusion in this problem, yes, sorry, that is very confusing. This version is exactly the same, only you say list.get instead of list, or instead of nums with the square bracket. For r equal, so this works, but it's like kind of messy. So let's take a look at how we would clean it up. So the first thing the student is checking is seeing, like, are the lengths of the two arrays the same? Because if they're not the same length, we know that the two arrays aren't equal. So they're saying, okay, if they're the same, now let's do some other checks. And then way down here in the else connects to this initial if. And so if they're not the same, then we return false. The reason why this is hard to read is because, like, you have to sort of jump back and forth with your eye to figure out what's happening. Like, if you're thinking about all this stuff down here, by the time you read down here, you may have forgotten what the else was about, and you kind of have to go back up and say, oh yeah, I remember what it was about. So I think a more direct thing to do would be to test for the condition that lets you act immediately. So in our case, the action that we could do immediately is if this weren't true. So we could say if num1.length doesn't equal num2.length. In that case, we know that right away they're not equal, so you could just immediately return false. And that would exit right away. And so now we don't need an else, and so this whole thing becomes a little bit easier to look at. Here, I actually want to keep this where it is so that we can compare and contrast at the end. Oops. We have this same problem here. We have return statements and an if and an else inside a loop. So this is just going to exit immediately. So let's take a look at sort of what a cleaned up version of this looks like. This is a little bit nicer, and actually let's make a one-line if, just because I kind of like it. Well, I don't know. I'm of mixed feelings about this. So some people think that you should never have a one-line if like this. And we'll talk about more why they say that when we get to class. Okay, so here we're saying if the arrays aren't the same length, right away we know they're not equal, so we'll return false. Otherwise, let's loop through the array and let's compare the adjacent values. Sorry, not adjacent. Let's compare the corresponding values. So we're comparing location I for one array and location I for the other array. And if those two aren't the same, again, we know the arrays aren't equal, so we'll return false. And if we haven't ever returned false, then we know that all of these must have been equal, so we can return true at the end. Some students misinterpreted the problem, and they tried to figure out, like, do the arrays contain the same values regardless of their ordering? But that wasn't the question that I'd asked. In my pseudocode, I said pretty clearly you only need to check corresponding locations. And so in that case, this is going to work just fine. The problem of figuring out whether or not the two arrays contain the same set of values regardless of ordering is sort of one step harder. Okay, last problem, shuffle. So this student is using a random object, which is actually not my favorite. I would prefer you to use math.random and cast to int all the time. The other thing is this student is recreating their object inside a loop, which is probably a bad idea because it's going to be like really, really slow and may affect the pseudo-random values that you get. So let's do this. Let's create... Well, and I said we didn't want to do that anyway, so let's delete that entirely. Okay, so we're looping 500 times, and here they're trying to generate a random integer between 0 and 8, it looks like. And so our way of doing that would be to say math.random times 9. That should strike you as very strange. You should be thinking, why 9? The reason why 9 is because this student's test array was length 9. But the problem is the method can take an array that's any length. So this is case in point why you don't want to use a number like this. It's called a magic number because nobody knows why it is that. So a.length, that's going to be a good approach to doing this. And now this little snippet of code here is saving a value and then overwriting that location and then taking the saved value and putting it where we had copied from. So this swaps the two values in the array. Okay, so that looks pretty good. The only issue here is, like, if our array was 1,000,000 elements long, probably doing 500 swaps is not going to be enough to randomize it sufficiently. How many would be enough is sort of a tricky mathematical question. But, you know, the bulk of the idea here is kind of there. What did this student do? So this is an interesting version that does not work. The student is trying to select two random indexes from the array. They're off by 1 because, remember, math.random doesn't actually go up to whatever value you're multiplying it by here. So actually you want to go up to a value that's 1 too large for what you're looking for, because math.random isn't going to let you hit that value anyway. Let's see, we don't really need these parentheses here either. That's a little weird. And I think that this is going to work. I think it does the multiplication before it does the casting. It might not, actually. I think it might do the casting before the multiplication. Anyway, it's probably safest to group, to say, let's do the multiplication first and then do the casting. Whoops. Because otherwise, you would immediately take this number, make it 0, and then multiply 0, and that wouldn't work. Okay, the more important bug is here. So as soon as we run this line of code, the old value at index 1 is gone. We've saved over top of it. So here, when we try and use it, we're actually taking the value from index 2. So, like, let's pretend the value at index 2 is the value 5. So we're taking 5 and we're copying it to this location. Now we're saying, let's take this location and save it back to index 2. But this location is now 5 because we just changed it on the last line. So this is actually going to end up destroying the value here, and both index 1 and index 2 are both going to end up being whatever this was. So this does not perform a swap. Very important and common bug. Okay, I hope that was helpful. That is all.